Good day, students. I am Sir Raymond, and today is another chance to learn math, so make sure to watch the entire video. For a polynomial, no matter how many terms it has, always check for the greatest common factor first. That's why in this video, we are going to talk about common monomial factoring. By definition, it means a factoring method wherein the goal is to get the greatest common factor or GCF first. For better understanding, let us take a look into the process of common monomial factoring by having example number 1. Factor 14x cubed minus 7x raised to 5. Step number 1. Consider first the numerical coefficients. Find their GCF. In this particular example, as we can see, the numerical coefficients are 14 and negative 7. What you're going to do is to list all their possible factors. For number 14, the factors are 1 times 14 and 2 times 7. Whereas for positive 7, because we don't really have to consider the negative, we have 1 times 7 and that's it, because 7 is a prime number. Based from the list of factors, we can say that the GCF or the greatest common factor of number 14 and 7 is 7. Okay? Once done with the numerical coefficients, focus now on the variables and exponent. So we're going to take a look at the x cubed and the x raised to 5. All you have to do, class, is to compare the exponents. And then you're going to choose and copy the variable with the lower exponent. So in this case, we are going to copy x cubed. So write x cubed in here for step number 2. After that, combine the GCF and the chosen variable. So in this case, we are going to have 7x cubed. Now, this is our common monomial factor. After obtaining the common monomial factor, which is 7x cubed, use this to divide the given polynomial like what I will show you now. So copy the given polynomial, which is 14x cubed minus 7x raised to 5, and then as I've said, you are going to use this common monomial factor to divide the terms of the given polynomial. Divide first the numbers. 14 divided by 7, we have 2. Applying quotient rule, 3 minus 3, we are going to have 0. So therefore, our answer is only 2. Next, negative 7 divided by 7 is negative 1. But before we write number 1, let's check first if the exponents of the second term will give us a difference. And in this case, it's x raised to 5 divided by x cubed, which means 5 minus 3, and therefore we are going to get x squared. So write x squared. And now we are down to our final step, which is to copy our first answer together with our second answer. And thus, for the given 14x cubed minus 7x raised to 5, our factors are the quantity of 7x cubed and the quantity of 2 minus x squared. So once again, this is our factors. Now let us have another example. Example number 2. Factor 9x raised to 4 y raised to 3 plus 27x raised to 2 y minus 63x raised to 5 and then y squared. So just like what we did on the previous example, the first thing that you have to do is to identify the GCF of the numerical coefficients, which are 9, 27, and negative 63. Okay, so on the side, let us first get the factors of 9. Okay, so we will have 1 times 9 and 3 times 3. Now for 27, we have 1 times 27 and then 3 times 9. Now let's get the factors of 63. Now for 63, we have 1 times 63, 3 times 21, and 7 times 9. Looking carefully at the list of factors, we can say that the GCF is 9. Here, here, and then here. After getting the GCF of the numerical coefficients, let's now proceed to comparing the variables. In this case, we have two variables, the x and y. Of course, we are going to focus on the x first. Compare the exponents. On the first term, it's x raised to 4. On the second term, it's x raised to 2. And on the last term, it's x raised to 5. Remember that what you're going to choose is the variable with the lower exponent. So we are going to choose x squared. While on y, we are going to choose also the one on the middle term. Because in the first term, the exponent is 3. In here, the exponent is 1. And on the last term, the exponent is 2. So definitely, the y having the lowest exponent is the one in the middle. So copy y. Now, use this together with our GCF, which is 9, to divide the terms of the given polynomial. Again, just copy the given polynomial. And then after copying, you will have to divide using the common monomial factor, which is 9x squared y that we get earlier. So divide each term by 9x squared y. So 9 divided by 9 is 1. So we're not going to write it anymore. Apply quotient rule once again for the exponents. For minus 2, we have x squared. 3 minus 1, we have y squared. Copy the operation. 27 divided by 9, we have 3. 2 minus 2, applying quotient rule again on the exponents. So we're not going to write 0 anymore. And then in here, 1 minus 1, and once again the answer is 0, so we're not going to write it anymore. Okay, let's proceed to the third term. Negative 63 divided by 9. So our answer is negative 7. Apply once again quotient rule on the exponents. 5 minus 2, we have x cubed. And then finally, 2 minus 1 is y. Just like what we did on example number 1, we are going to combine our first factor here to the second factor here. And that's going to be our factors for the given 9x to the 4th y cubed plus 27x squared y minus 63x raised to 5 y squared. Okay, let's do that. Again, our factors are 9x squared y and the quantity of x squared y squared plus 3 minus 7x cubed y. Okay, so this is our final answer.